OK, so we're going to take a look at the structure and functionality of the Zippy microservice. And if you recall, the Zippy microservice was the one that we used with the QuoteServices case study, which took requests from a client and then used the Jakarta Persistence API, or the JPA, in order to return back the requested quote objects back to the client. And this microservice is going to use both Java parallel and sequential streams, just a little bit for one of the method implementations. But it's primarily going to use the Jakarta Persistence API. By the way, you may wonder why it's called the Jakarta Persistence API. It used to be called the Java Persistence API. And what happened apparently is that the Eclipse Foundation is the maintainer of this software repository. And for various reasons, Oracle wouldn't let them use the word Java in their name. So they had to change it to Jakarta. If you know much about the history of, I think it's Indonesia, Java is the country and Jakarta is the capital, if I understand it correctly. So here's the Zippy application. Just a quick recap of this. We've got an application that is going to extend the base application, and it's got a main method, and it has a run hook, which is used to start things up. So that's pretty much the same as before. The ZippyController at this level is the same as before. When we look at the implementation code shortly, we'll see we've tweaked a few things. But basically, ZippyController extends the base controller and is parameterized by a list of quotes. You'll see why we parameterize the return type when we take a look at an upcoming example that will switch from using classic Java types like lists or maps to reactive types like fluxes. And so being able to parameterize this helps us with code reuse. So again, pretty much the same. Now let's talk about something in a little bit more detail, and we're going to add a new twist to it. So we have this thing in this Zippy application microservice called the JPAQuoteRepository. And that's basically a Jakarta Persistence API-based repository that contains a database of quote objects that we can query in various ways. And you can see here there's the JPAQuoteRepository. You can see where you can find it. And it extends an interface that comes out of the box with the JPA called JPARepository. And the JPARepository is a nice little facade that abstracts away from a bunch of basic create, read, update, and delete operations like save and find all and find by ID and find all by ID and so on that enable interactions with a database, which could be in memory or could be persistent, while having to write little or no SQL. We'll see that we can mostly write no SQL. We have to write a little bit of code to get SQL. We'll talk about that in a second. So we also have another interface. This is the part that's new, called multi-query repository. And that provides a method that returns a list of quote objects that match all the queries in a list of strings that are passed as a parameter. And that's going to be new and very cool. And you'll need to understand how this works for your upcoming programming assignment 2B. And then we have another method here, which is something we just wrote using support from IntelliJ. And this is called find by quote containing ignore case. And what that does is that finds all the quote rows in the database whose quote column contains the query string in a case-insensitive way. And what's cool about this is a good example of how the Spring Data API, which we'll talk about in more detail in a second, allows us to do things declaratively, and then it generates the code automatically to do the underlying SQL query. So this particular sequence of words will cause the JPA to generate a method that will do this SQL query. Select everything from the quote table where the lowercase quote column is like the lowercase query added wildcards added to it. So that means it'll match anything that's in there. So you don't have to have an exact match. You just have to have it included in there or contained within there. So the nice thing about that is you don't have to know or care about SQL. You just have to know how to write these keywords into the names of the methods that are part of the JPA repository that you're implementing. Now let's quickly recap how the ZippyService is structured. So it implements the base service and parameterizes the return type as a list of quotes. And we make it a service. And then we define ourselves an auto-wired JPA quote repository. And this, of course, will be used by all the methods that we have in the ZippyService, which we inherit from base service, or we inherit the interfaces from base service. So get all quotes, turns around and says, hey, repository, please give me all the Zippy quotes. And the query that corresponds to that, that's generated automatically for you, is select everything from the quote table. Again, you don't have to know how to write that. You just have to know how to do call to find all. That's generated for you kindly by JPA. The post quotes method takes a list of quote IDs and a Boolean, which we ignore here, and it calls the find all by ID method, which is also automatically generated by the JPA repository. And here's what the query looks like. Select everything from the quote table where the ID field is in, and then these question marks correspond to each of the integers that are part of the quote IDs list. So that's what gets generated automatically there, which is pretty cool. And then the next method is the search method. And in this one, we, for various reasons, don't use a generated JPA call directly, and that's because there's no way to do that, as we'll talk about in the next part of the lesson. But we do use this find by quote containing ignore case method, which is automatically generated, and we just sort of wrap a parallel stream around this, or a sequential stream, depending on what the Boolean parameter is. And so that'll go ahead and find all the quotes objects that match any of the queries in here, winnow out the duplicates, and then return a list. And then again, this is what the generated SQL query looks like. We already looked at that before. The last method here, and this is really what we're going to talk about in more detail in the second part of this lesson, is the searchEX method. And this one is going to take a list of queries and a Boolean that's ignored for this implementation. And what it's going to do is it's going to find all by quote containing all in. And that's a custom SQL method that we have to write, or custom method that we write, that will generate an SQL query programmatically, as you'll see in a minute. And that will return all the quote objects in the database that contain all of the queries. So they have to have everything. Whereas this one returned stuff that had any of the queries. So this is any, and this is all. And so we're going to take a closer look at this in just a second, but I wanted you to kind of see the big picture view of how all these things fits in. And I've updated the code on the repository that includes all this stuff so you can see how it works.